4.1, number 5. We have a system of linear equations here, and we want to solve it by graphing. So first what we need to do is get 3 ordered pairs for the first line and graph it. So we're going to go ahead and get our XY chart. And pretty much always find x is 0, what's y is 0, what's x, and then pick some other value, just as a checkpoint. And then we need to do the same thing for the other equations separately. And again, we're going to pick x is 0, find y is 0, find x, and then pick anything for x, and I like 2, so I usually pick 2. So for the first guy, x is 0. Well, if x is 0, that's gone, and I end up with y is 3. That's all that's left, so y equals 3. If I pick y is 0, that piece is gone, and I'm left with x equals 3. If I have x is 2, well, if x is 2, let's go ahead and solve the equation that results. 2 plus y equals 3. And you could do it this way also for x is 0. Just put in x is 0, solve for y. You'll end up with y is 3. And now here, solving for x is 2, what's y? We take away 2 on both sides, and we get y equals 1. So we have 3 ordered pairs for the first equation. Next equation, if x is 0, that term is gone. I'm left with y equals 3. If y is 0, that term is gone. I'm left with minus x equals 3, or dividing both sides by minus 1, x equals minus 3. And then if x equals 2, well, let's go ahead and solve that. Y, take away x is 2, equals 3. Add 2 to both sides. We get y is 5. So now we have a chart for each equation, and we're going to go ahead and graph the equations on the same graph. Wherever they intersect, that is the solution for the system, because that point lies on both lines. It's a solution for both lines, and that by definition is the solution to the system. So we get x and y. And it looks like as long as we go between minus 5 and 5 everywhere, we'll have enough room for all the points. 1, 2, 3, 4, 5. So each square is worth 1. 2, 3, 4, 5. And you might notice on my math lab, 4, 5. Sometimes the squares are worth 2 each or something like that. And that's fine. Just be careful when you're counting that you remember that they're worth 2 each. So our first line, the very first point was 0, 3. So 0 for x, 3 for y. Second point was 3 for x, 0 for y. And the checkpoint, to make sure that we have a straight line like we should, was 2, 1. Yep, they look like they're lining up. So that means that we calculated correctly. And then we make the line that goes through the center of all 3 points. And extend it pretty far so that you'll have lots of room for an intersection. Definitely use a ruler and graph paper when you're doing these, otherwise the intersection can be way off. Second line, first point, 0, 3. Oh, look at that. It happens to fall right on the other line, so I have a funny feeling that's our intersect. Minus 3, 0. 1, 2, 3. And 2, 5. 1, 2, 3, 4, 5. And our 3 points lined up, which means we got our line correctly. Draw a line through the center of the 3 points. And now the intersection is the solution. The intersection point is 0 for x, 3 for y. Now let's do a quick check. X plus y equals 3, and y minus x equals 3. Take the original equations, put your point into each one. It has to be a solution to both of them. So 0 plus 3, does it equal 3? Yes. And then 3 minus 0, does it equal 3? Yes. That means it's a correct solution.